Okay, this is going to be lesson 40, Algebra 1. And we're going to review the properties for exponents. And we're going to learn about the quotient rule for exponents. So let's do some review. So we have a definition. We said that we have x times x times x times x. It equals to x to the n power, which means n is the number of factors. So this would be x to the fourth power. Right? We learned the product rule. The product rule said we have x to the m times x to the n. It's simply x to the m plus n. So x squared times x to the third is equal to 2 plus 3, or x to the fifth. Remember, again, we have to have the same base. X is called the base, and these little numbers are called the powers or the exponents. We have another definition. We said x to the 1 power is simply x. Then we had another definition that said if x is not 0 and it's to the negative n power, then the same thing as 1 over x to the n. Well, it's called the reciprocal. We change the negative, just like 1 over to the n is equal to x to the negative n power. Then we had another definition that said x to the 0 power is equal to simply 1. That's been one of our newest ones. So now we're going to learn the quotient rule. We've been using it. We just haven't known that we've been using it. So we're going to learn the quotient rule for exponents. So it's really an extension of the other three rules. So let's look at, what if we wanted to do x to the fifth times 1 over x squared? Well, we could use our other rule and rewrite this to say x to the fifth times x to the negative 2. Remember, by moving this to its reciprocal, we change the sign, so it now becomes a negative 2. And what do we know about that? Isn't that x to the 5 plus negative 2, or simply x to the 5 minus 2, which is equal to x to the third power? That's simply our answer. So now we can do the same thing, but in one step with the quotient rule. And the quotient rule says if you have x to the m divided by x to the n, then you have x to the m minus n. It's important that you know this. It's the power of the numerator minus the denominator. Now let me also show you this. We had x, 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 x to the fifth over times 1 over x squared, x, x. Don't these simply reduce to 1? Those reduce to 1. You're left with 1 at the bottom, and you're left with x cubed over 1, or simply x cubed. Exactly how the quotient rule works. So let's look at a couple. Let's look at a couple different ways. So it says simplify x to the sixth over x to the fourth. It said first write the answer with the x in the numerator. So we're going to change this to x to the sixth times x to the negative 4, which gives us x to the sixth minus 4, or x squared. Now we could have done the same thing in the quotient rule without this extra step. We could have simply done x to the sixth minus 4 equals x squared. We would have gone straight from here to here and ignored that step. But either way is right. So if you feel more comfortable doing this and using the product rule, go right ahead, because when you start getting into negatives, then it becomes a little trickier. So let's look at a few more. So let's look at, well, they wanted to use the same one, and they want to do this in the denominator. So we've got 1 over x to the negative 6 times x to the fourth is really what they're saying. They skipped that step. I put that in for you. Plus 4 equals 1 over x to the negative 2 power, or simply x squared, which is what we got the first time. So let's look at another one with the negatives. This is when it becomes a little trickier. So we have x to the sixth over x to the negative 4. And all you have to remember is, what are your integer rules? What is your rule for the quotient rule? And then how do you apply integers? How do you use integers? So basically you have, here you can switch this to the numerator, if you want, say x to the 6 times x to the 4th, because that's how I get rid of that negative, is x to the 10th power. But if we use our quotient rule, we have x to the 6 minus a negative 4, which is equal to x to the 6 plus 4. Because what is a negative and a negative? Times a negative, it's going to give you a positive. So you get x to the 6 plus 4, which we get this answer right here, x to the 10th. So you just have to be careful with your exponents. Now, they worked it where it also x to the 6 over x to the negative 4. And they worked it where you have 1 over x to the negative 4 minus 6 equals 1 over x to the negative 10, or simply x to the 10th power. Okay? This, I'm using the definition, and if you look on page 160, you should write all those definitions in that box. That will help you for even your test that you're about to take. Because when you have a negative exponent, to get rid of the negative exponent, you do its reciprocal, which is x over 1, and then the power becomes positive. If you have a negative, it's still going to be negative. That does not affect the power, the definition of the powers. So, let's look at another one. Again, don't let these exponents mess with you. Okay, so we have x to the negative a over x to the b. So they're the same basis. We have x. We use our quotient rule, negative a minus b, or simply, that's your answer. If you want to get rid of the negatives, you could have put this to the bottom and said 1 over x to the b plus a. You could have done 1 over x to the b plus a by simply moving this down here. So these two are the same, it just depends on how you want to read them. And they're called equivalent expressions, and it doesn't matter because it depends on the personal preference. Some questions might tell you leave them all in the numerator. Some of them might say have all the exponents in the denominator. Some might say we want all positive exponents. Some say leave your answer in all negatives. So you got to know how to go from x to the 4th to 1 over x to the negative 4th, and 1 over x to the 3rd. They say 1 all in the numerator, nothing in the denominator. This becomes x to the negative 3. Okay, so you got to know this definition. It's really important. Okay, so let's move on. Let's do one more. Let's do this example. X to the negative. Let's put it all together. Y to the 6z all over z to negative 3 y squared x. We can use our exponent rules. Well, first of all, you can either leave it and do this in your head, or you can rearrange it. X, y, put them in alphabetical order. So then you can see. So then I have x to the negative 5th minus 1 times y to the 6th minus 2 times z to the 1 minus a negative 3. Because it's a negative 3, you still minus the denominator. So you simply are going to have x to the negative 6th power times y to the 4th. Use your integer rules. Negative and negative is you add them and you keep the sign. Find the difference. Here you have 1 plus 3, so it becomes z to the 4th power. And that is simply your answer. Okay? You could look it like that. You could put it where they're all in the denominator, so it becomes x to the 6th. Y to the negative 4 is z to the 4th, or they could have put all positive exponents, which would have been y to the 4th, z to the 4th over x to the 6th. That's the same answer. Or you could have made them all negatives, which would have been x to the negative 6 over y to the negative 4, z to the negative 4. Okay, so let's do the distributive property. Using these rules. That's why you got to use these rules, because then we start using these to complicate distributive property. Again, we're using rational expressions with exponents. X squared over y minus 4y cubed over x squared. Okay, we have a parentheses. How many terms do we have inside that parentheses? We have 2, because remember, a term is separated by a negative. Alright, so these look a little different than ones we were working in class because they have a denominator with the variable in it. So now they've become fractions. You can't combine them unless you have what? Common denominator. So we're not even going to go there yet. So right now we're just going to worry about simplifying this. And to simplify this, because there's 2 terms, we have to distribute. Remember we said the operation for distribute property is multiplication. So we simply have to take this whole thing. So you have x squared over y squared, y, minus, keep the sign, x 4y cubed over x squared, y squared. So now we're going to simplify, and we get x cubed over y cubed minus, did I write the problem down right? Oh, yes. Minus, now these 2 can cancel out, and these 2, so I've got 4 over, because remember I had 3 minus 2, which is y to the first, and then I have 1 minus 2, which is x to the negative 1, and then if I want to write that with positive exponents, it becomes x cubed over y cubed minus 4y over x. Or you could simply say that crosses to 1, this crosses to x to the first power, this crosses to 0, and this crosses to 1. Okay, so that's your answer. Let's do another one, a little bit more complicated than this. So now, in order to simplify, we're just using our rules for exponents. So let's look at one more. So let's look at 4x to the negative 2 over y to the 4th x squared minus 3x to the 4th over y to the negative 2. Okay, so here we're just, it looks complicated, but it really isn't. We're just using what are our properties in our rules. So, distributive property, 2 terms, multiply by each one. So we have 4x to the negative 2, y to the 4th, x squared, all over y to the 4th, minus 4x to the negative 2, 3x to the 4th, all over y to the 4th, y to the negative 2. So now we're going to use our exponent rules to simplify this. Well, I know this and this is the product rule, and negative 2 and positive 2 is x is 0, or simply 1. And then here, with my quotient rule, 4 minus 4 is 0, so that becomes 1. So I simply have 4. Then I've got 4 times 3. I can't forget that, and I can't forget my negative. So that's 12. Negative 2 plus 4 is x squared. 4 plus negative 2, because this is still multiplication, even though it's in denominator, so it's y squared. And I could have said I want all numbers in the numerator. So then I would have 4 minus 12 over x squared y to the negative 2, because to move this to its reciprocal, I change its sign on its exponent. You don't change the sign here, you change the sign on the exponent. Make sure you keep that clear. Right? Do your practice problems, and the code is 399 less than 38. 399 less than 38.